So go to the next page. We have y equals 2 and then 2 to the x power. We need to figure out what that 2 is going to make it do. Okay, if we multiply it by 2, what is it going to make it do? All right, and if you remember, that number in front is going to stretch it. So stretch by a factor of 2. At the beginning of the year, we kind of talked about how it was steeper or flatter based on what that number was. So this is just a different way of saying that. It's going to stretch. Next one, y equals 2 to the x plus 3. Okay, so you see how that plus 3 is in the exponent with the x? Okay, if you have a number that's with the x, okay, whether it's in parentheses, in the exponent, underneath the square root, it's going to go left or right. And if you remember, it does the opposite of what you think. Okay, so this plus 3 is actually going to move it to the left 3. So if you look at the next one, 2 to the x minus 3, how do you think that one's going to move? If now we have a minus 3 with the x. And it'll move it right 3. It does the opposite of what you think. If it's in parentheses, exponent, square root. Okay, if it's with the x, it does the opposite. Next one, y equals 2 to the x plus 1. Okay, do y'all see how that plus 1, it's a big number. Okay, it's at the end of the equation, it's out kind of by itself. That's going to move it up or down. And it does exactly what you think. So if I say plus 1, it's going to move it up 1. If I say minus 5, it's going to move it down 5. Okay, so if you have a number at the end, it's going to move it up or down. Okay, last one on that section, negative 2 to the x power minus 5. So we have two different changes going on here. We have a negative in front of our 2 to the x power. We also have a minus 5 at the end. So it's actually going to change in two ways. Okay, if you remember, the negative at the very beginning is going to flip it. Okay, so you can say flip. Technically, we say it's reflected over the x-axis. Okay, and then the minus 5 is going to move it down 5. Okay, so it's going to flip and go down 5. Okay, let's do the next section. The next section is all about logs, but the changes kind of go hand in hand with all these parent functions. They do the same thing. So if I have a number at the end and it's plus 3, it's going to go up 3. And it doesn't matter if it's a cubic function, square root, log function, exponential. If I have a number at the end, it's going to move it up or down. So all of these changes work for all of the functions. So the first one, we have a minus 1 in parentheses. So since it's in parentheses with the x, it's going to move along that x-axis, left or right. And remember, it does the opposite of what you think. This will move it to the right 1. Okay, the next one, log base of 2 of x minus 1. Now, it's not in parentheses this time. It's just at the end. Okay, so this is actually going to move it down 1. Y equals negative log base 2 of x. So this one has a negative out in front. Remember, the negative is going to flip it. So you can say flip, you can say reflected over the x-axis, either one. Y equals log base of 2 of x plus 1. Okay, the plus 1 is in parentheses. It's with the x, and it does the opposite. So it'll move it to the left 1. Log base of 2 of x plus 1. And this one doesn't have any parentheses. Okay, so this plus 1 is actually going to move it up 1. And then the last one, 2 log base of 2 of x. So on this one, we have a 2 in the beginning. Okay, anytime you have a number at the beginning of your equation, whether it's linear, quadratic, whatever function it is, it's going to stretch it. Okay, so this one is going to be stretched by a factor of 2, whatever that number is. All right, next page, we're going to practice transforming these graphs, and then based off what we've learned, and then we're going to actually graph them. Okay, so let's see. Number 1. We have y equals 2 to the x plus 1. So I want you to write out what type of transformations is going on here. So ask yourself, what is the 2 going to make it do at the very beginning? And that 2 is going to stretch it. The plus 1 on the end is going to move it up 1. Okay, we aren't going to fill out the table. I don't want to get real picky on what type of points are going to be on the graph, but I do want to see that you stretched it and moved it up 1. So this exponential function that normally has a horizontal asymptote at 0, okay, we're going to take that asymptote and we're going to move it up 1. Okay, so instead of it being at 0, now it's going to be at 1. That point that's normally at 0, 1, we're going to move that point up 1. So now it's at 0, 2. And then we're going to make our graph. Make sure whenever you draw it, it looks a little steeper because we are stretching it. Okay, so I'm looking for that horizontal line to be at 1. I'm looking for that point that's normally at 0, 1 for this graph. I'm looking for it to be at 0, 2. Okay, your domain for exponential functions will always be negative infinity to positive infinity, or all real numbers. Your range. Now this time my range isn't going from 0 to infinity, it's going from 1 to infinity. Okay, my lowest point here is going to be 1. It gets really, really close to it and then goes up for forever. Make sure that 1 has a parentheses around it because it doesn't actually touch this asymptote. It just gets really close to it. Okay, and my asymptote is going to be y equals 1. All right, let's skip a couple. Let's do number 4. Let's see a log function and see how that looks. Okay, so number 4, we have y equals 2 log base of 2 of x plus 3. So I want you to tell me how it transforms. Okay, what is that 2 at the very beginning going to make it do? And it's going to make it stretch. The plus 3 at the end, since it's not in parentheses, it's going to move it up or down. And since it's a positive 3, it'll move it up 3. So we're going to stretch it and move it up 3. Now, normally your log function has that vertical asymptote, and you can look back at the front page of your notes. If you ever forget, keep these notes out so you have it. But this vertical asymptote, since we're not moving left or right, that vertical asymptote is going to stay exactly where it's at. The part that's going to move up 3 is that point that's normally at 1, 0. And like I said, you can look at the front page of your notes if you forget. The point that's normally here at 1, 0, we're going to move that up 3. 1, 2, 3. And then draw your graph. And you want it to be a little bit steeper because we are stretching it. But I do want to see your asymptote, and I do want to see that point at 1, 0. I want to see that you moved it up 3. All right, our domain. Okay, our domain for this function is going to be from 0 to infinity. And we're going to use parentheses. Okay, or you could say x is greater than 0, either one. Our range for log functions, your range is always negative infinity to positive infinity, or all real numbers. Oops. And my asymptote here, since it's vertical, is going to be x equals 0. Okay. All right, so once you have that, turn to the back. We're almost done with the notes. And then you can do your worksheet. Your worksheet's almost exactly like the notes. So definitely keep these out so you have it.